E.2 Questions number 4 through number 6. Another 3 questions. Number 4, when we do the binary search on a 20-element ordered array and assume that the search key can be found in the array, how many elements in the array correspond to the worst case? Yes, worst case. Yeah. Here, the question is slightly different. So when you read the question, read carefully. Yeah. So this question, we do not ask you to find the number of comparisons for the worst case. We do not ask you for that. All right? Yeah. The number of questions for the worst case, you use the formula. We have 2 formulas, right? Yeah. So that is. So I hope you do not get confused. So when you look at the question, you do not read carefully. You just find the number of comparisons for the worst case. I hope you do not do that. Yeah. But here I just review the formula for the worst case. 2 ways you can write. One way is this. Another, n plus 1. All right? They should give the same answer. Anyone you like to use. All right? But here, the question is how many elements in array correspond to the worst case? You should draw the binary tree that corresponds to the binary search. After you draw that tree, you can count the number of nodes at the bottom level, because the bottom level corresponds to the worst case. Yeah, so let's do it in that way. All right. You have 20 elements. Yeah, so here, the first time, let me just write all the 20 elements. Later, you can do the calculation. Yeah, because the first time, it is hard to do the calculation. All right. Yeah, so let me just write all the elements here. All right. Yeah. Then we draw the binary tree corresponding to this array. All right. Yeah, let me just remove. Yeah. We do not use this formula here. Yeah. Let me just remove. Last one, 20. All right. Yeah. Now, let us draw the tree carefully. Binary tree. Median. First median. We know. Even number of elements. So the median, we use the left median. So 10 should be, node 10 should be on top at the root. Yeah. Then 2 branches going down. Left branch, 5 is the median, right? Yeah. So 5 should be here. All right, yeah. Right branch from 11 to 20, yeah. 10 elements. 10 elements, the left median, right? Yeah. This one, left median. How about that? All right, left median, right median. So 15 is here, all right? Yeah. All right, then 4 elements, so 2 should be here. Left median, yeah. 1, all right. 2, 3, 4, right? 3 is the left median. 4 below. All right. So 5, right-hand side. 4 elements, 7 is the left median, then 6. Then 8 and 9, 8 left median, 9. All right, yeah. Then 15, 4 elements, left median, 12. Then 11. Right branch, 2 elements, 13, left median, then 14. All right, yeah. So now, remaining 5 elements, 18 median, 16 and 17. Then 19 and 20. Yeah. This is the binary tree that corresponds to the binary search. All right. So you can see the top level, the node at the root, that this is the best case. All right. Then the bottom level. All the nodes at the bottom level corresponds to the worst case. All right? Yeah. Then you count the number of nodes, 4 or 5 nodes, right? Yeah. So the answer equals 5. How about that? How about that? All right? Yeah. So this example, we draw the tree. We draw the binary tree. It takes a lot of time. Yeah. But later, let me give you the general formula. General way. General method. If you know the general method, you do not need to draw this tree. Very time consuming, right? Because if I give you 100, do you want to draw a binary tree with 100 nodes? No. You may need 1 hour to draw it, right? Yeah. We don't want to spend that long to draw that big diagram. All right. So here, the general method. Yeah. First, we need to find the largest k minus 1. Yeah. Because a 4 binary tree with k levels, yeah. Level we can start from 0, okay? 0, 1, 2, 3, k minus 1 has this many nodes. All right. So now we look at what is the largest k to have this condition. Here we want to get the largest k. What is the largest k? Here, k equals 4 is largest k, right? 16 minus 1. Yeah. So the largest k equals 4. All right. So you'll find that largest k to satisfy this inequality, the first step. Second, you use 20 minus that largest k, 2 to the 4th, minus 1, 15. 20 minus 15, that is your answer 5. That is the general method. All right. If you use the general method, then let's calculate another question. Another question, n equals 100. Yeah. Because this time, nobody can draw binary tree with 100 nodes, right? Yeah. Tedious work. Too much tedious work. Yeah. We don't want to do that. All right. Let's calculate what is the largest k minus 1 less than or equal to 100. 6, right? Yeah, 6. K equals 6. Because when k equals 6, 64 minus 1, 63. Yeah. So now we use 100 minus 2 to the 6th minus 1. 100 minus 63 equals 37. this is your answer. That 37 is your answer. Okay, so when I give you a question like this one, you use this general method to get the answer, not drawing this big tree. All right, yeah. That is the question number 4. Question number 5. So this time, 25. This time also, probably the first time. Yeah. Oh, yeah. This one, we have 2 ways. One way, draw the binary tree. Okay. Yeah. Method 1. Still draw the binary tree corresponding to the binary search. All right. Too much tedious work, so we may like to avoid it. All right. Method 2. Can we use the previous method we just discussed in the previous slide? Yeah. Calculate the number of nodes at the bottom level. At the bottom level, all right? Yeah. The same way we used in the previous question. Yeah, we can do that. Yeah, let's do the calculation. 2 to the k minus 1 should be less than or equal to 25, right? Yeah. And we know the largest k should be 4, right? Yeah. So then the number of nodes at the bottom level should be 2 to the 4th minus 1. So what's that? 15. So 10. All right. Now, the average formula. All right. One comparison, multiply 2 to the 0th power. Yeah, because the root, number of nodes, 2 to the 0 plus. Then 2 comparisons, 2 to the 1st power. All right. Yeah. 3 comparison times 2 to the square, second power. 4 comparison times 2 cube. All right. Yeah. So then 1, 2, 3, 4. 5 comparison times 2 to the 4th. Yeah, the question. Yeah. Right. Yeah. So this last term we should be careful, right? 2 to the 4th. We get to this 2 to the 4th, right? Yeah. We should not use. Yeah, because 5 comparison, but this time we do not have 2 to the 4th number of nodes. We just have 10 nodes, all right? Because the last level, it's not 4, all right? Last level, only 10 nodes. Yeah, 10 nodes, yeah. So 1, 2, 4, 8, yeah. Because the previous 4 levels, 1 plus 2 plus 2 squared plus 2 cube, you have 1 plus 2 plus 4 plus 8, right? So you have 15 here, 15 plus 10, total 25, right? So you should, the numerator, you have that. denominator 25. Denominator 25. Then you can find the answer, 25. The answer, even if you do not find the end, do not calculate this number, it is okay. I know you can do the calculation for that number, but here you can see that's the way we calculate the average number of comparisons for the binary search. Okay, average case performance. The key step, the last term, you need to figure out the last term. Then you can write this formula correctly. All right, so the last question of this part. This time we need to solve second order recurrence, homogeneous recurrence relation. Second order linear homogeneous recurrence relation. We need to solve that. All right. Step 1, find the characteristic equation. Step 1, characteristic equation. All right, so what's that? X squared minus, because you move 2 times x to the left-hand side, 2x minus 1 equals 0. That's the characteristic equation. Second, you use the quadratic formula to calculate the 2 roots. Negative b, so that's 2, plus minus b squared, that's 4, minus 4 times negative 1 over 2a. So let's simplify it. 1 plus minus root 2. All right, that's the step 1. All right. Step 2, general form. General form of the solution. Okay, so what's that? The general form of the solution. All right. Because here we use a, so probably my coefficient, I use little a and b. All right, general form of the solution. So that is a of n equals little a constant times the solution, 1 plus the first root to the nth, plus little b times 1 minus root 2 to the nth. General form of the solution. Okay, the second step. The third step, determine a and b. A and b using the initial condition. Initial condition. All right, so that's these two. All right, you're plugging a 0, so 0 equals a plus b. All right, so the b equals negative a. So then 1 equals, you're plugging 1, so a times 1 plus root 2 plus b times 1 minus root 2. And a b, you can replace b by a, right? 1 minus plus 2 minus a, 1 plus 1 minus root 2. All right. Take A out. Inside parentheses, do simplification. Cancel out 2 root 2. Yeah. So you get A equals 1 over 2 root 2. B negative A, right? B equals negative 1 over 2 root 2. Yeah. Step 4, write the final solution. Yeah. You have the little a value, little b value. So your final solution, a of n equals 1 over 2 root 2, parenthesis, 1 plus, let me just, 1 plus root 2 and minus 1 minus root 2 to the n. How about that? Right? These 4 steps, can you solve in this way? Yeah. So that's the typical way we use to find the solution of second order linear homogeneous recurrence relation. Don't miss it. All right? So let me stop the video E.2 right here.